All right, let's take a look at section 12.2, the fundamental counting principle. In this section, we want to understand the fundamental counting principle, use slot diagrams to organize information in counting problems, and know how to solve counting problems with special conditions. The fundamental counting principle, FCP, if we want to perform a series of tasks and the first task can be done in A ways, the second can be done in B ways, the third can be done in C ways, and so on, then all the tasks can be done in A times B times C ways. Example, a group is planning a fundraising campaign featuring 2 endangered species, one animal for TV commercials and one for use online. The list of candidates includes C for cheetah, O for otter, F for the black-footed parrot, and T for the Bengal tiger. In how many ways can we choose the 2 animals for the campaign? Solution. We first choose an animal for the TV campaign, which can be done in 4 ways. We then choose a different animal for the online ads, which can be done in 3 ways. So the total number of ways to choose the animals is 4 times 3, which equals 12. 4 being the 4 ways to choose an animal for TV, and 3 being the ways to choose a different animal for online ads. How many ways can 4 coins be flipped? Flipping the first coin can be done in 2 ways. Flipping the second, third, and fourth coins can also each be done in one of 2 ways. The 4 coins can be flipped in 2 times 2 times 2 times 2 ways, or 16 ways. 4 tasks each done 2 ways. The first coin can either be heads or tails. The second coin can either be heads or tails, and so on. How many ways can 3 dice, red, green, blue, be rolled? Rolling the red die can be done in 6 ways. Rolling the green and blue dice can also be done in one of 6 ways. The 3 dice can be rolled in 6 times 6 times 6 ways, or 216 ways. A summer intern wants to vary his outfit by wearing different combinations of coats, pants, shirts, and ties. If he has 3 sports coats, 5 pairs of pants, 7 shirts, and 4 ties, how many different ways can he select an outfit consisting of a coat, pants, shirt, and tie? Solution. The intern's options are systematically listed in this table, where our first column is the task of selecting a coat, selecting pants, selecting a shirt, and selecting a tie. And our second column is the number of ways to perform that task. 3 coats, 5 pants, 7 shirts, 4 ties. If we multiply 3 times 5 times 7 times 4, we get 420 outfits. Number of coats times number of pants times number of shirts times number of ties. Slot diagrams. A useful technique for solving problems involving various tasks is to draw a series of blank spaces to keep track of the number of ways to do each task. We will call such a figure a slot diagram, where the first task is listed in the first box or space or line that you draw, and the number of ways is written inside of the box or on the line. And then you have a space times a space times a space times a space times a space, where each space, which is represented by a box or a line, is your first task, your second space, your second task, your third space, your third task, and so on. And on that space location, you write the number of ways to perform that task or to select that item. A security keypad uses 5 digits, 0 to 9, in a specific order. How many different keypad patterns are possible if any digit can be used in any position and repetition is allowed? The slot diagram indicates that there are 10 ways to do the first task, 10 ways to do the second task, 10 ways to do the third task, 10 ways to do the fourth task, and 10 ways to do the fifth task. So if we multiply 10 times 10 times 10 times 10 times 10, we come up with 100,000 possibilities. 100,000 keypad possibilities. In the previous example, suppose the digit 0 cannot be used as the first digit, but otherwise any digit can be used in any position and repetition is allowed. Then the solution changes by representing the first task as the restriction that we cannot use 0. So the slot diagram indicates that there are 9 ways to do the first task, 10 ways to do the second task, 10 ways to do the third task, 10 ways to do the fourth task, and 10 ways to do the fifth task, making 9 times 10 times 10 times 10 times 10 ways, or 90,000 possibilities. In the previous example, suppose any digit can be used in any position, but repetition is not allowed. Then, whatever we choose for the first task, for the first digit, can't be used again. So repeats are not allowed. The slot diagram indicates that there are 10 ways to choose the first digit, 9 ways to choose the second, 8 ways to choose the third, 7 ways to choose the fourth, and 6 ways to choose the fifth, making 10 times 9 times 8 times 7 times 6 possibilities, or 30,240 possibilities. Example of handling special conditions first. A college class has 10 students. Louise must sit in the front row next to her tutor. If there are 6 chairs in the first row of the classroom, how many different ways can students be assigned to sit in the first row? Solution. We first consider the following tasks. Task 1. Assign 2 seats to Louise and her tutor. Task 2. Arrange Louise and her tutor in these 2 seats. Task 3. Assign the remaining seats. Task 1. There are 5 ways to assign 2 seats to Louise and her tutor. They can either sit in seat 1 and 2, seat 2 and 3, seat 3 and 4, seat 4 and 5, or seat 5 and 6. Task 2. There are 2 ways that Louise and her tutor can sit in their seats. Louise sits either on the right or on the left. Task 3. The remaining 4 seats are to be filled by 4 of the 8 students left. Thus, we have 8 students for the first remaining seat, 7 for the second seat, and so on. So we have 5 ways to choose the number of seats for Louise and her tutor, times the 2 ways to seat Louise and her tutor in the 2 seats, times the number of ways to seat 4 of the 8 students in the remaining 4 seats. So 8 possible students for the first chair, 7 possible students for the next chair, 6 possible students for the next chair. As people sit down, only 5 students available to sit in the last chair. Therefore, giving us a total of 16,800 total possible seating arrangements for that first row in the classroom.